So once again, good morning. So we are discussing with module 3, that is linked list. In linked list, we have gone with various types. Next, we have seen the applications. So application means where you are, how you are going to implement stack using linked list. Next, we have gone with the concept of queues using linked list. Okay, so these are the two applications you have in linked list part. So now in the previous class, we have gone with a stack implementation using linked list that you can see in this particular previous video lecture, and it's already recorded in the YouTube also. You can subscribe for the channel and you can see. So in today's class, we are going with a new concept, that is queue using linked list. So what is the queue using linked list, that we shall see in today's class. So what type of queue? So similarly, we have gone with a different types of queues. For example, linear queue. Next, we have gone with a circular queue. Next, we have gone with a double-ended. Okay, so linear queue, circular queue, double-ended queue, priority queue. So many queues are there. So in that, so we use which queue is implemented using linked list. So you have four types of queues: linear queue, circular queue, priority queue, double-ended queue. So in that, which one we are going to see? We are going to see the linear queue. Okay, so linear, you know the word, we are implementing the word linear queue. So we are implementing linear queue using linked list. Okay. So in now you come for the explanation of that. So in that you are going to have how you are going to insert an element into the queue and how you are going to delete an element from the queue. Okay. So the queue which is implemented using linked list is called as a linked queue. So queue which is implemented using linked list is called as a linked queue. Okay. So now you come for the concept. So under this, now you are having queue. We maintain how many pointers? We have two pointers. One is the front pointer, the other one is rear pointer. So front points to the first item of the queue and rear points to the last item of the queue. So items are added from the front and deleted from the rear. So keep this one in your mind. So what you are going to do? So is it correct? Is this statement is correct? Is this statement is correct? Can anybody can tell? No. So what is the statement? Correct the statement here. How the items are added from which end? So it has given as items are added from the front and deleted from rear. So what is the exact answer? So exact answer is you are going to add the elements from the rear end and delete from the front end. So it's correct. So you are going to add the elements from rear end. Priya B. Okay, good. So you are going to add the elements from the rear end and delete from the front end. So insertion and deletion will not be in the middle of the queue. Okay. So now you come for the insert of queue. So insert of queue means operation adds a new node after rear end. Okay. So keep this in your mind and moves rear to the next node. So where is actually if this is the last one. So kindly I am teaching you, first you go through the class, then you ask me the questions. Don't you have sense of when to ask the questions and all? So insert of queue. So insert of queue means adds a new node at the rear end. Okay, so after the rear, if you are adding a new node, so once it is, this is the rear end. Okay, so if this is the rear end, you have to add a new node and move the rear pointer to the next node. So this is the rear end and this one is the front end. If you want to insert a new node, so this new node should be inserted after the rear end. So where is the rear pointer? Rear pointer is pointing at 4. Okay, so rear it is pointing at 4. So for that one, you have to add a new node after the rear. So that can be 5. Okay, and move the rear to the next pointer. So rear will come to the newly inserted node. So similarly, come for the delete of q. So under delete of q, what you will do? It will remove the front node and moves the front to the next node. So this is the front end. So if you are deleting the node, so which is the node you are having at the front end? So it is item number 9. Okay, so number 9 will be deleted and the front will point to next node. So where the front will point to the node, this one, which is containing an element 1. Understood. So how you are going to implement the linked list, so that we shall see it in this following steps. So this is the algorithm to insert in a linked queue, and this is the algorithm if they ask you the steps. So procedure or steps to insert and delete. So you have to write what are all the explanation and steps. Okay, so don't go for the program. So you have to answer what is the steps. If they ask you the write the code or explain with the program, you have to write the program. If they ask you to insert or delete, so it will be up to writing the steps. Okay, so you have to give the explanation of that. So come for the linked queue representation, this yellow part. So step 1. So step 1 means allocate the space for the new node pointer. So this is the allocation you have to take. How you allocate? Using malloc operation. So allocate the space for the new node. That is new node, we consider it as PTR. PTR is the new node. Okay. So next set PTR then data is equal to val. So you have added a new one. So new, okay, if you are adding a new node, so first you have to insert the data. So what is the data? That's why we are taking it as PTR then data is equal to val. So this is the value for new node. Understand? This one is value for the new node. So you already know the linked list will consist of two fields. So if we are representing using single linked list, it consists of data field. The other one is next field. Keep this one in your mind. Okay. So first you take a new node, that is PTR. Next you assign PTR then data is equal to val. So after that, now you have to set the pointers. So which is the pointer you have? So here we are having two pointers. One is the front, the other one is rear. You have to set the two pointers. If front double equals null, if front double equals null means, so when q is empty, so front is equal to null means there is no element. So at that time we take it as q is empty. So if q is empty, then you are placing a new element. So you are placing a new element, and that element, the front and rear will point at that element only. So understand this one carefully. We are taking a new node, and for new node you are giving the data. If there is no ಕ್ಯೂನೇ ಇಲ್ಲ, ಹೊಸದಾಗಿ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಸೊ at that time you go with the word front is equal to null. So when you get null, when there is no elements in your queue, so at that time we give it as front is equal to null. So if front is equal to null means there is no queue and you are creating a new node. So that's why we take it as front is equal to rear is equal to PTR. So PTR is the new node. So for that only node, so because it is the only node you are having. So what is the node? So PTR is the node. So for that PTR, you are making front and rear point to that PTR only. Okay. So similarly, now you have to check with next pointer. So front then next is equal to rear then next is equal to null. If there is only one node, so where that everything will point. So one node will pointed by front and rear, and front then next and rear then next is equal to null, because there is no next node. Next node illa, only one node ಇದೆ. At that time you have front then next is equal to rear then next is equal to null. So null means, so this will be the null. You can see in the diagram, if there is only one node, so that will be pointed by front as well as rear. So front then next and rear then next both will be pointing to null. If else, come for else means, so already the q, the elements are there. When you get the else part, when q is there with elements, sorry, I can take it as nodes. Q is there with nodes. For that node, you are adding a new node. Already keep this one in your mind. Already 9 is there, already 1 is there, already 7 is there. So already 4 is also there. So at that time, what is the case? So this one, if there is no Q, so at that time, this is the condition. So if Q is there with nodes, so at that time, what you will do? You go with the last one. So last one is 4. So rear then next should point to the new node. So what is the new node? New. Where is the rear then next? So the rear element is 4. So rear then data is equal to 4, and rear then next should point, it's having null, and that should be pointed by what? PTR. So what is the PTR? PTR is the new node. Okay, so what is the PTR? So what is the rear? It is node number 4. Node 1, node 2, node 3, node 4. Node 4, then next should point to new node. So either continuation. So after rear, you are having a new node. So that one, so rear, then next should point to PTR, and you have to make rear is equal to PTR. So once you insert a new node, so this rear will move to there. So that's why we give it as rear is equal to PTR. So once you make rear is equal to PTR, now you have to make rear then next is equal to null. So ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. So this is the rear case. So rear end, so you are inserting a new node at the rear end. So that's why we're taking it as rear then next. Null giddiddu. Now you are pointing to where? PTR, and that PTR you are making it as rear end, and for that rear end, so newly inserted node, so you give it as 5 as the value. So rear end, you give it 5 as a value, and its next pointer should contain null. So that is the condition. Are you getting? Are you people getting? Only one response. Brunda Hiremat, are you there? Brunda Hiremat. Okay, I think she has gone. So this is the algorithm to insert a node in the linked list. Now you similarly you come for deleting an item. So if you want to delete, what you have to do? So if you want to delete an item, first you see if friend is equal to null means if friend is null means there is no queue. So this is the case. If friend is equal to null, so what is there? Queue is empty, so no elements to delete. So at that time you go with as underflow condition. So else if q is if q is not null, is not empty, so what you will do, set ptr is equal to friend. So set ptr, what is this ptr? The node to be deleted at the front. So what is the node you are having? So node is number 9. So node is number 9. So you are deleting that one. So you are making it as PTR. Okay. So set front is equal to front then next. So where is the front? So front is been pointing at 9. So where is the front then next? So front then next is nothing but this is the front. Okay. So front then next. This is the next pointer. Next pointer is pointing to node 1. Okay. This one is node 9. You take it. Node 9, node 1, node 7, node 4. Okay. So now you are deleting the front. So what you will do, set the PTR is equal to front. Okay. So next you have to make front then next. What is front then next? It is node 1. So make that one as front because you are deleting this particular front element. So that's why if you want to delete this particular node, what you have to make, move the front to the next node. So that's why we are taking where is the front then next is pointing to. So front then next is pointing to node 1. So make that one set to front. So this front will be moved to node 1. So when this pointer is moved to node 1, you can free this particular node. So what is this node? This node is called as a PTR. So you call at the time you call it as free of PTR. Understood? So this is the algorithm. So now you come for the program. So under this, it's the entire thing is been placed here. So this and this are the very important part. So first you start with a insertion. So keep this one in your mind. What I am marking. This is for insert the queue elements, and this one is the function for deleting the queue elements, and this one is for displaying the queue elements. Then similarly you will have the main function. So first you start with a enqueue. Enqueue means, are you able to see this program? Are you able to see this program? Okay, then start with a NQ. NQ means you are inserting the queue elements into the linked list. So you have to keep this one. Sorry, see this algorithm. It will be very useful if you go with a program. If you understand these steps, you can easily understand this particular lines. Okay, so first you go with a NQ. So Q will consist of how many pointers? So first you write the front pointer, next you go with a rear pointer, and next you go with an element. So what is int I? I is nothing but an element what you insert at the info field of the linked list. So what is I? It is an element. Understood? So for what is the first step here? Allocate the space for new node PTR using malloc. So you are allocating the space. So that's why we are taking struct node new node. Okay. So struct node new node should is the syntax. So new node you have to allocate dynamically. So how you allocate dynamically? Using malloc. So malloc that will be given like this: new node struct node star malloc size of struct node. So this is the syntax used for dynamic allocation of the new node. Okay. So first initially, now you see, so you have to go through each line. New node, then first part is info part. You can take it like this. New node, then info is equal to I, and new node, then next is equal to null. So this happens if there is no node. Okay, so if this is the first syntax, new node then next is equal to null, new node then info is equal to I. So what is the new node? For that you have to insert two fields. One is the info field that will be filled with value I, and the other one is the next field that will be given the value null. Okay, so if friend double equals null, so if friend double equals null means there is no element in the list. If there is no element in the list, so front end will be null. At that time, the new node we set front is equal to rear is equal to new node. So that will be given like this: front is equal to new node, and then you go rear is equal to new node. So when you have no elements in your queue, so at that time you are inserting a new node. So that new node only we are having front and rear pointed. Okay, if front not equal to null, that's why we are going with a else condition. If front not equal to null means already the elements are there. So at that time what you will give? Rear then next is equal to new node. So at rear end you are going to have a new node, and set new node is pointing to rear. So rear then next is equal to new node, and rear is equal to new node. So that we shall see here. No, rear then next is equal to new node is nothing but PTR, and new node is equal to rear is equal to PTR. So that's why we take it here. Rear then next is equal to new node, and rear is equal to new node. So this is the condition for inserting the elements into the queue. Now you come for the delete condition. So delete queue of, because you are going for a deletion at only one end. So which is that end? That we consider it as front end. So what you will be giving for that? First take that node as temp. So what is this temp? So it is node to be deleted. So the node to be deleted, we consider it as temp. If front not equal to null, so if front not equal to null means elements are already there. At that time, what you will do? So make temp is equal to front. Okay, so temp is nothing but front element. So now you move the front pointer. So temp is equal to front. So after that, now you move the front pointer from front to next. So move the front pointer from front to node, because here we have, here you can see from front then next is pointing to node 2. Front pointer is moved from node 9 to node 1. So I am telling like this: node 9, you are moving to node 1. So you have to move this front pointer. To where the front pointer is to be moved? It's to be moved from front then next. So front is equal to front then next. So front is equal to front then next. Then you free that temp. So this is for delete operation. Understood? So now you come for the display operation. So under display operation, you are going to display all the contents starting from the front end. So from front end, if front not equal to null, that means the queue, the elements are there. At that time, you go with front not equal to null. You are printing all the elements. So front dot info. So it has to, next you have to again go with front is equal to front then next. So first initially this will be the front end. So if front not equal to null, first you print the front element. So how you print the front element? By using front dot info. Suppose if you want to go for the next one, what you will do? Front is equal to front dot next. So first you will print with 9. Next you go, first you will print 9, that is front element. Next front then next is nothing but node 1. So 1 will be printed, next again 7 will be printed, next again 4 will be printed. If you insert any other, so that element will also be printed here. So that's why that is print. So now you come for the main function. So initially front end and rear end will be marked with null. Okay, so now you come for the do. Now I go with a do while loop. So do means, so execute the all the execute the statements, then check for the condition. So for that I will be giving finished is equal to 0. So go with the queue operation, insert, delete, quit. Okay. So you enter the choice. So choice of switch of choice. Choice 1 for insert, choice 2 for delete, choice 3 for quit. Okay. So case 1. So enter the element, now you call a function. So front comma rear comma choice. Okay. So element we consider it as choice only. Okay. So that element, now after that now you come for the case 2. So case 2 is nothing but delete of queue from front. So break. Next case 3 finished is equal to 1. So once you finish with all the cases, print the contents of the queue. So display from where? So display of front. So from front, next you go with a front is equal to front, then next. So that will go with a node 1, node 4, node 9, like that. Okay, so keep on doing while not equal to finished. So while front not equal to null. So you have to repeat again. So that is rear is equal to front, then next free of front. Okay, so this is the program on how to you go with a how you perform the implementation of queue using the linked list. Here you can see the output of that. So first we have gone with the insert, delete and quit. Choice 1 we have inserted 11. So 11 then null. So now again you have inserted the choice 1. So element is 22. So it will be 11 then 22 then null. So again, you have gone with a choice 2. So if you go with a choice 2, which one will be deleted? So you are having two elements here. One is 11, the other one is 22. So which is at the front end? Front end is pointing at 11 and 22 is pointed by rear. But if you see this first option, there is no list. So for that you are inserting a new node. So new node is nothing but node 11 is the first node. So at that time, if there is only one node, rear pointer and front pointer both will be pointing at that node 11 only. Okay, so when you again insert, now you see the front pointer is pointing to 11 and rear pointer is pointing to 22. So now you see you are performing a delete operation. So delete operation means which you are deleting the node at the front end. So where is the front end pointing to? So front end is pointing to 11 and that one will be deleted. So now you see front then 22 then null. Okay, so this is the operation of linked list queues using linked list. So apart from that, now you have review questions. So these are some of the review questions that we are going to give it here. So use this link to answer your attendance. So these are the review questions that you can consider. Okay. So push operation of the stack, to application of stack, to application of queue, and you can answer this particular questions. So this is up to stack and queues linked list operations. So